Is the truth value of a conditional determined by the truth values of its antecedent and consequent? If it is, there has to be some specific way in which the truth value of the whole conditional depends on the truth values of those parts, meaning there are four possible ways of assigning truth values to the antecedent and consequent: true, 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 false, false, true, and false, false. Supposing that the truth value of the whole conditional is just a function of the truth values assigned to those parts, there has to be some truth value that the whole conditional has whenever it has a true antecedent and a true consequent, some truth value it has whenever it has a true antecedent and a false consequent, and so on. So if the truth value of a conditional is determined by the truth values of its antecedent and consequent, what is the conditional's truth value in the first case, where it has a true antecedent and a true consequent? What is its truth value in the second case, and the third case, and the fourth case? Only 16 answers are even theoretically possible. It could be true in each case. It could be true in the first three cases and false in the last case, and so on and so forth. Of the 16 theoretically possible answers, are there any that are plausible? Logicians have argued that we can narrow down the options to just one that has any shot at being correct, namely the fifth option shown here. And here's one way of arguing that that's the only viable option. First, consider the second case where the antecedent of the conditional is true, but the consequent is false. An example would be, if Los Angeles is the most populous city in California, then it's the capital of California. There, the antecedent is true. LA is indeed the most populous city in California, but the consequent is false. LA is not the capital. Surely in this case, the whole conditional is false. So we should put F for the whole conditional in this second case. Now consider the first case where both the antecedent and the consequent are true. Suppose we put F in this first case too. That would mean that a conditional is false when it has a true antecedent and a true consequent, and also false when it has a true antecedent and a false consequent. So putting F in this first row would mean that a conditional is false whenever its antecedent is true. So that would mean that there's no such thing as a true conditional with a true antecedent. But a very common form of reasoning involving conditionals, known in Latin as modus ponens, goes, if A then C, A therefore C. If there can't be true conditionals with true antecedents, then the premises if A then C and A can't both be true together. So we'd never be able to use modus ponens reasoning to go from two truths to another truth. But surely we do that all the time. For instance, a student might know that if there's a sign on the door saying that class is canceled, then class is canceled. Then notice that there is indeed a sign on the door announcing that class is canceled, and so conclude correctly that class has been canceled. There, the student uses modus ponens reasoning to go from two truths to another truth. So because we need to allow for the possibility of both premises in modus ponens reasoning being true, we better put T for the whole conditional in this first case. Now consider the last case where both the antecedent and the consequent are false. Suppose we put F in this case. Well, that would mean that a conditional is false when it has a false antecedent and a false consequent, and also false when it has a true antecedent and a false consequent. So putting F in this last row would mean that a conditional is false whenever it has a false consequent. So there would be no such thing as a true conditional with a false consequent, which means that a conditional and the negation of its consequent could never both be true. But another very common form of reasoning involving conditionals, known in Latin as modus tollens, says, if A then C, not C, therefore not A. And if a conditional and the negation of its consequent can't both be true, then the premises if A then C and not C can't both be true. So we'd never be able to use modus tollens to go from two truths to another truth. But that's another thing we do all the time. For instance, a student might correctly believe that if there's a homework assignment due tomorrow, then the course website will say so. Discover that the course website does not say that, and so correctly conclude that there is no such assignment due the next day. There, the student uses modus tollens reasoning to go from two truths to another truth. So, because we need to allow for the possibility of both premises in modus tollens being true, we better put T for the whole conditional in the last case. Now, finally consider the third case, where the conditional has a false antecedent and a true consequent. Suppose we put F for the whole conditional in this case. Then a conditional would be true when its antecedent and consequent have the same truth value, and false otherwise. So now consider the conditional if C, then A. Its antecedent is C and its consequent is A. In the first row, its antecedent and consequent have the same truth value, so it would be true in the first row. And in the last row, its antecedent and its consequent have the same truth value, so it would be true in that row as well. So it would be true in those rows, and it would be false in the other two rows where its antecedent and consequent have different truth values. So the conditional is if A then C and if C then A would always have the same truth values. But the conditionals if A then C and if C then A are not in general equivalent. There are many examples where one of those conditionals is true but the other is false. For instance, it's true that if I have $1 billion, then I can afford to eat out at a nice restaurant. It's not true that if I can afford to eat out at a nice restaurant, then I have $1 billion. Because we don't want if A then C and if C then A to be equivalent, we better put T for the whole conditional in the third case. Now, let's be clear about what the argument that we just looked at really shows. What it shows is that if we're going to say that the truth value of a conditional is determined by the truth values of its parts, that is, if we assume that one of these 16 theoretically possible answers must be correct, then we better say that the truth value of a conditional is determined by the truth values of its parts in the specific way indicated here, because none of the other options are viable. What hasn't been shown is it actually is plausible to say that the truth value of a conditional is fixed by the truth values of its parts in this way. Even if that's the best option for someone who wants to say that the truth value of a conditional is a function of the truth values of its parts, it still might not be a plausible idea overall to say that a conditional is false whenever it has a true antecedent and a false consequent and is true in every other case. So how plausible is that view? We'll explore that briefly next time.